Hello, I'm Reid with Intelligent Controls, and today we're going to be talking about charge controllers. I have in front of me here a couple of examples of charge controllers. An older tech PWM charge controller by Victron, another larger unit of similar technology, and a couple of our MPPT maximum power point tracker charge controllers by Victron. Both of these options can do the job. The older PWM, which anyone who has used solar for longer than about 10 years will probably recognize, is based on the method of allowing charge to occur when your solar array is at the ideal voltage for your battery bank to charge. This system essentially acts like a relay with an open-close gate that protects your batteries from inadequate voltages. This offers some critical protections, like making sure your battery bank doesn't get overcharged and that the voltage is within the range your batteries need. This technology also has a couple of downsides. Your solar array needs to have a voltage that matches the charge your batteries want. You lose charge ability anytime the voltage is not within the thresholds you need. For example, at any time the sun is not hitting your panels just right. So array sizing and angle orientation is critical. This means you will have a limited window of charging each day on a good day. So obviously we're looking at why the MPPT is a superior charger. The primary reasons for this are based on how these charge controllers function at their core. Rather than only allowing charge to go to your battery bank when the array has the perfect combination of light, voltage, and amperage, we can stack the deck for the benefit of your batteries. An MPPT controller does not depend on the input from your solar system to exactly match the conditions your battery needs to charge. It matches those two systems for you. This advanced functionality allows your solar and battery systems to work together for maximum efficiency in a wide variety of temperature and lighting conditions, creating optimal charging for your battery backup. So rather than making our array match the battery voltage, we will increase the voltage on the array. The MPPT then takes this higher voltage and converts the output down to the exact voltage that your battery needs. The bonuses here are: 1. Charge can occur in a much wider range of lighting conditions because we can reach the minimum voltage with less light. 2. The voltage charging your batteries is specific to the state of charge of the battery and can increase as the battery nears full to allow a full topping off of that battery. This is especially helpful when charging lithium batteries with their much tighter charge specifications. These 2 points, in combination with the excellent charging algorithm that Victron MPPT charge controllers use, can result in as much as 40% quicker charging during ideal light, as well as the ability to start charging earlier in the day and continue charging until much later in the day. We also have fewer parallel connections in our array, reducing the amount of failure points, as well as significantly reducing the amount of wiring you'd require in a large system. Also, because of this higher voltage, we end up with less line loss, and we can use smaller wires to run the same distances. That's more power, smaller wires, and less voltage loss with the same number of panels. Practically speaking, this means you could get 30 to 40% more performance out of the same solar array just by switching out your charge controller from a PWM to an MPPT and reconfiguring your panels primarily from parallel to mostly series connections. Put another way, this also means you could have a smaller array and get the same performance. Let's take a look at a couple of really basic examples. If we put 3 100-watt panels in parallel and run them through a PWM, each panel is designed to charge a 12-volt battery, so when the panels are hit with enough light to make a voltage that's high enough to start charging your 12-volt battery, the PWM will open a contactor and allow amperage through to your batteries. This means that your panels will have the ability to charge when the light is strong enough to get that voltage up. This is probably going to be when the panels are at least 80% of their maximum power, or most likely only during a few hours at the middle of a day on a good clear day. What about that same set of 3 100-watt panels used with an MPPT? In this version of the system, we're going to run those same panels in series, raising the voltage from something like 18 volts up to closer to 60 volts. This allows us to get a charge current going when the panels are getting light that is less than 30% of their maximum voltage per panel. And then as the light increases, they're able to give more and more and more charge current. This means that a set of southward facing panels will be able to start charging much earlier and continue charging later in the day than the same set of panels using a PWM. In everything we've seen in real-world installations, MPPT technology is hands down the most effective solar charging technology out there, and Victron's SmartSolar MPPT charge controllers are the most effective and easy to use charge controllers that we've used. If you have any question about Victron's line of MPPTs, check out our website for related technical articles. Links are below. And if you'd like assistance with sizing an MPPT for your system, feel free to get in touch with us directly. As Victron distributors, it's our job to help you design the system that's right for your application. Hit the like and subscribe buttons below to stay in the loop with intelligent controls and any of our future videos. Thanks for watching. Have a great day.